Way we start with crude oil. I think you learned already about it. You take your crude oil, you put it in the distillation column, and you set the distillation column at different temperatures. Then you're going to have different products. Among the products you will get from the distillation column is your diesel. And the technology is called oil processing. Are we together? At the end of the day, you get your diesel. Good. And this technology is currently used by different companies like Total, like Alf, like Chevron or Shell. They do have different wells where they dig crude oil and they convert it in diesel. And the diesel is used to run trucks, cars, and so on. The second product, or the second feedstock which is used to produce diesel is the natural gas. And the technology is called the GTL. The GTL stands for gas to liquid. You start with gas, which is the natural gas made mainly by methane, ethane. I'm saying mainly methane. Methane is more or less between 80% and 96%. And you do have some other product like ethane and so on. You convert methane into natural gas. It's what we call the gas reforming. I think, do you still recall? You start with methane, you convert it to natural gas. We call that process gas reforming. And after having the same gas, not natural gas, the same gas, you can now convert the same gas into hydrocarbons. Among the hydrocarbons that can be produced, diesel is one of them. Are we together? Good. So this leads also to the production of diesel. The last one by South Africa, one of the companies using this is Sasol. Sasol use coal to produce diesel. They start with coal, they burn it, they produce CO2 and the same gas is combined in a catalytic reactor producing the diesel. And we call this process Fischer-Tropsch Nyasha. So this process is called Fischer-Tropsch. Why Fischer-Tropsch? Just because according to the history, during the Second World War, Germany suffered about what we call the embargo. It means that other countries could not sell their gasoline or diesel to Germany. Do you think without fuel you can run your tanks or you can run your cars? They couldn't. And because they were suffering about the lack of fuel, they hate at least the scientists. They say, no, we cannot remain like this. Though we don't have, we cannot buy, we cannot get, let's say, gasoline or diesel from outside, we can make it by ourselves. And the man who thought about the process, his name was Fischer. And his friend, his name was Tropsch. They said, no, we can make gasoline or diesel from coal. They developed a catalyst based on iron and nickel or cobalt, and they were able to produce diesel from coal. That's why the process is called today Fischer-Tropsch. This is the Fischer-Tropsch. This is the method used to produce diesel. And it's beautiful, and this is used by Sasol. But this GTL is used by PetroSA. PetroSA used GTL to produce diesel. But the point now, what worries us is this, guys. All these processes, when let's say, for example, they burn coal, this is coal. When they burn it to produce the syngas, in order to use Fischer-Tropsch to get diesel, by burning this in air, they produce, or when they use also the vapor, they produce the syngas, but at the same time they produce also a huge amount of CO2, which is not necessary to produce your hydrocarbons. Now, the CO2 which is produced, where is it going to go? Because they produce a huge amount of CO2. Where is it going to go? Where is it going to go? It releases into the environment. And this is what's causing today the climate change, or basically what we call the global warming. So the global warming is caused by the release of the what we call the greenhouse gases. Among them is the carbon dioxide, which is released via the Fischer-Tropsch, the GTL, or the oil processing. But we say that we are part of the green team. After finding that this is not green because the climate is keeping changing due to this, we cannot remain indifferent. We're supposed to do something. This is where we got the idea to be making the same product but using something which is more friendly. And that product is the vegetable oil. Is it okay? However, we could not start with any kind of oil because at the end of the day, there is a costing effect that will play a role for the implementation of our technology. If you use an oil which is already expensive, what should be your expectation at the end of the day? The finished product is supposed to be expensive. We are saying that we want to cut the cost of the diesel, but how are we going to cut the cost if the feedstock is not more cheaper? That's why we look at in Africa, which oil is more cheaper? Go to search again. Palm oil. Are we together? People will tell you about the waste oil. But if you start with the waste oil, number one, you should be able to collect the waste oil all over all the restaurants. Number one. Number two, the waste oil is not pure as such because it goes under a certain transformation. When you cook, I think ladies, they know, when you cook food, at the end of the day, if you analyze your oil, it's going to be more acidic. Are we together? You put lemon, you put a lot of stuff. So that's your oil, which is a waste. Though it's a waste, but before to use it to produce diesel or biodiesel, it's supposed to be purified. Are we together? And in engineering, it's very important. If you have to purify oil, it's going to cost you even more than the crude oil. That's why you need to be careful. And I used to tell you as engineers, guys, we don't have any choice. While you are developing your process, you have to think already about the costing. Otherwise, you should just stop or be working only to publish, to have articles published. Are we together, guys? Good. So this is the reason why we went up for this project or the production of biodiesel using a magnetic heterogeneous catalysis. So basically, the aim of this project, this is the outline. We're going to talk about the aim objectives, the literature review briefly, because you need to understand how you can produce biodiesel from palm oil. Because if you don't understand the theory behind that, how are you going to be making the biodiesel in the industrial scale? So we're going to look at the results that we got last year, and the conclusion, and also some suggestions for those who are working this year. As we said, our feedstock to produce biodiesel is the palm oil. The palm oil, I think you've already seen it in our lab. It's a very viscous oil. I'm supposed to read the samples, huh? Okay. It's a viscous fluid which is extracted from the fruits. That's what we call the palm fruits. And the palm fruit, if you cut it, has got 3 different parts. I don't know if I can call the outside the flesh. English speaking people, can I call it the flesh? Sagunda, can we call this part? This part. Okay, great. This is the external part where we extract our oil. When they take it, they remove it, they squish it, you can extract the oil. And that oil is very viscous. Okay, this is the palm tree. Why we choose palm oil, as we said, is the cheapest vegetable oil among all in the world. Secondly, it's because it's sustainable. Do not forget, we are part of the green team. But we don't take any feedstock to say we're going to make our product. That feedstock is supposed to be sustainable. Are we together? It means that you should not have something today and it's finished. Tomorrow it's not there. No. And palm oil is fulfilling that requirement. And also is abundant. If you go to country Angola, Gabon, DRC Congo, Cameroon, Nigeria, it's very abundant. This is the reason why it's even cheaper. And you know, just in brackets, I would like to tell you, today Malaysia, go to check on the internet. The economy of Malaysia is booming up. And the product that is booming up the economy of Malaysia is the palm oil. Why? Just because Malaysia is producing now petrol from palm oil. And because of environmental aspects, Europe, even USA, they start putting the requirement that you cannot put 100% diesel or gasoline that they are selling from the station. It's supposed to be mixed with a certain percentage of biodiesel. And the oil which is more cheaper is the palm oil. That's why USA and other countries, they are importing now palm oil from Malaysia. That's why the economy of Malaysia is among the greatest producers of the palm oil in the world. So, these are the reasons that led us to be using the palm oil. As you can see on these charts, if you look at the palm oil is the most produced oil among all in the world. And the other raw material that we're going to be using to produce our palm oil, it's going to be the ethanol. The ethanol is one of the alcohol. I will explain to you chemically how it works. We're going to use alcohol. Our alcohol is ethanol. Other people are using methanol, but for us it's not really convincing. Why? And this is where I would like to draw your attention. When you're going to be discussing with people, just be sharp. I will explain to you how to make biodiesel from palm oil and alcohol. People claim that they can use methanol. You start with palm oil or vegetable oil plus alcohol. It gives to you biodiesel plus glycerol. The choice of the feedstock is very important when you are targeting a certain production. Because if your feedstock is not abundant, is not renewable, because we are targeting also the renewability of our products, it's going to be a problem. People use generally methanol. If you read more than 1,000, 2,000 publications for the production of biodiesel, is based on methanol. But I would like just to tell you, you must be careful. It's not the number of articles that makes the process efficient. Are you with me? But it's rather the engineering aspect, because at the end of the day, we need to tell ourselves, if we use methanol, to produce biodiesel. Ask yourself the question, how methanol is produced? Do you have an idea how methanol is produced? I think you did it in chemistry. How methanol is produced? 8% of methanol produced in the world is coming from the Fischer-Tropsch process. 98%. I might be slightly wrong, but between 95 and 98 is produced from Fischer-Tropsch. So if now we use methanol to produce biodiesel, what does it mean? What does it mean?
We have to produce first methanol, which will cost us more. Then after we have to use that methanol to produce biodiesel.
Yeah, this is one of the reasons. Yes, but what is wrong using methanol? It's not eco-friendly. Because look at guys, we go for biodiesel because we say that we don't want this to happen to our universe, our let's say planets. But methanol is produced from Fischer-Tropsch. But people use methanol to produce biodiesel. What does it mean?
It defeats the purpose.
Huh?
It defeats the whole purpose.
Definitely, my friend. It's like you are saying, okay, I want to run away from water. It's raining. Let me get inside of the river. Are we together? Are we together?
Yes.
Are we together, Cedric? Anyone using methanol, I'm not saying you must be attacking people. Just make them to think. Why are we making biodiesel? We want to make green our environment. Okay? By running away from other technologies like Fischer-Tropsch and so on. But at the same time, one of the main products used without methanol, without alcohol, how are you gonna make your biodiesel? I'll show to you the mechanism. You need an alcohol, and the alcohol which most of the people you are using is methanol, because they will tell you it's cheaper. Yes, it's good to say cheaper. Even when you say cheaper, it depends where the methanol is coming from, the alcohol is coming from. Are you with me? Good. So basically, we say for us no methanol. Not only because it's not it's coming from Fischer-Tropsch, but also methanol is more toxic. And on top of that, we are not only green, but we are targeting renewable products. Are we together? Yeah. Is methanol renewable? Huh? But let's look at now ethanol. Is ethanol renewable? Why? Is ethanol renewable?
Yes.
Can you speak louder? Why is it renewable?
Because we can get it from palm wine.
We can get it from palm wine, and palm wine from palm tree. Yeah. Are you with me? Or you can get it from sugar cane. Let me tell you, in Asia is Malaysia, in America and South America is Brazil. One of the when economy boomed is Brazil. Today, if you go in Brazil, your car cannot run 100% diesel from the station. 50-50, they call it E50. 50% ethanol, 50% your gasoline or diesel from USA or other parts of the world. And today, the economy of Brazil boomed because of the exportation of ethanol. Brazil is producing a lot of sugar cane. So that's from sugar cane. They do the fermentation. Last year, we've been graced because one of the team was working on the conversion of palm wine, to ethanol, and we succeeded. We made it. So we could start with any kind of raw material. Brief. We're gonna use ethanol, as you can see here. We use ethanol to produce, we use palm wine, or you can use sugar cane to produce ethanol, which is renewable and more cheaper. But you cannot make the biodiesel. The reaction to occur, chemists will tell you, the reaction can occur, but it's gonna occur To produce 1 liter, you must take 1 month. Is it economically efficient? No. You need something to speed up the reaction, the kinetics of the reaction. And what can speed up the kinetics of the reaction? Wonderful. That's why we're going to use a catalyst. But you cannot use any type of catalyst. For us, this is where people used to find the green people very rush. Don't just tell me, okay, I'm going to use anything your biodiesel. You should be able to separate your biodiesel or your product with the catalyst, number one. Are we together? And the catalyst should be recyclable. It means that you should reuse again your catalyst after preparing your biodiesel. And after doing some search, we came up with the idea of using magnetic iron-based catalyst. And in the meantime, as I'm explaining to you this project, please, everything we share here should remain in the 4 walls of this hall, of this room. Are we together? Because we are getting to the heart of most of our projects. People, if you go to the internet, you will see how they make biodiesel. Anyone may say, I may try. Till we're going to hire you officially. We sign papers and we signed the agreement memorandum of, you know how it works. So that if you sell our product outside, you do get 15 years in prison. Until you sign a contract with us. Okay, good. So at the end of the day, we're going to have our biodiesel and the glycerol. How it works, guys, very simple. Okay, the aim, as I said, is to produce biodiesel from palm oil using a magnetic heterogeneous catalyst. Why magnetic heterogeneous catalyst is very simple. You did it in physics. You do have a solution. You want to separate what is inside with the particles which are inside. Using other methods, people use centrifugation. It's not easy. You need to use higher speed. But for us, we say, instead to use centrifugation, why can't I just take my magnets? I go with my magnet around. What's going to happen with the magnetic catalyst? This is what our people are working on. And the objective is to prepare the catalyst for the trans-esterification process, to test the catalyst, to recover the catalyst using magnetic separation, to characterize the catalyst by using different techniques, the XRD, the CEM. And you see the beauty of the project that we are doing. Each of you gonna find his portion. Okay? I know now my friend Takunda is becoming more engineer. But he will find his part because we will have to characterize our catalyst by doing the XRD, the SEM, the GC analysis to check if what we got is real biodiesel. Okay? And further on, guys, you will have now to design the proper reactor where we're going to be producing 250 liters of biodiesel per day. Don't think what you are doing there, yeah, it can be exciting, but the more challenging to produce 250 liters per day. So we can be making more or less for you 2,500 roughly per day. And so if you have to work per month and so on. But if we increase, that's going to be at a small scale. If we increase to big scale, 10,000 liters per day. And then you can see how much money you can be making out of it. Good. So, and here for the trans-esterification, this is where I told you, you cannot do chemical engineering without or by neglecting the chemistry, forget. And this is where I used to fight with my people from South Africa. I'm sorry, you cannot do chemical engineering without chemistry. So, even you as you're working, you must know the trans-esterification process, how it works. That is chemistry. The testing of the catalyst, that is chemistry. The characterization is chemistry. But it's only the design of the reactor that's going to be engineering, because you have to do the calculation of energy material balances. That is the engineering part. Is it okay? Good. So just imagine if you neglect your chemistry, then you're going to be in trouble. To make biodiesel brief, I would like just to say there are two ways people use either homogeneous catalysis or heterogeneous catalysis. There are advantages and disadvantages, but for us, we go for heterogeneous catalysis. So why for heterogeneous? Because when you use homogeneous catalysis, you will end up having a soap inside of your final products. And once you do have biodiesel with soap, what does it mean? You have to think about fair separation processes. And it's going to be so costly. That's why people use a lot of amount of water. Are we together? And it can make you about, that's why the current biodiesel made by people, it's expensive. Because it requires a lot of separation processes. And that's the reason why we moved from homogeneous to heterogeneous. For heterogeneous, you're going to read the advantages, they are there. And basically, we need now to understand what is the trans-ester fermentation. We said we start with the palm oil. The palm oil is made with what we call the triglycerides. You do have palmitic acid is there. You do have oleic acid. I think they know the composition. And what basically happens, this is your alcohol. Your alcohol is actually ethanol. What will happen? There will be a breaking up of this bond. So that's one OH function or radical will come to grief itself here, giving this spot. For the second alcohol, the OH will come to sit here, the third one will come to sit here, and this separation will give the first ester. The second, the third one. And look at now what is happening. You see, palm oil is very viscous. Why? Because of this, look at this molecule. This R is actually representing the chain, the rest of the chain. It's very long. It can contain 15 atoms of carbon. Are we together? And the second one can contain even 16 atoms of carbon and so on. So that if you put them together, because it's very long, how will be the viscosity of the substance? How it will be? You know, let me tell you, normally people could use even palm oil to drive cars. You know that? Normally they could use even palm oil. But they can't because it's so viscous. Now, to reduce the viscosity, what you're supposed to do? You have to do the cracking. Basically, you are doing the cracking. You are cracking. You are cutting here. You cut here. You cut here. You cut here. By cutting this only one, as there is no more bonds. How it's gonna make now the new product? Is it gonna be more is it gonna be viscous as the precedent? And this is the I can say it's the aim behind what we do. You still use oil, but you want to make it to become less viscous. That's why one of the characteristics of the biodiesel, when you are analyzing, it's going to be the viscosity. Are we together? So, the interesting part of biodiesel, and then I will show to you from the result you got from the GC. It will give you a product which is more or less pure. Because if you take the diesel from the fossil, okay, from the crude oil, it's a mixture of hydrocarbons from C11 to C19. Are we together? They won't tell you that the diesel contains just C17. No. There are a lot. There can be even 20 of them. Whereas for your biodiesel, generally for palm oil, you do have three main constituents. The palmitic acid, the
Oleic acid.
Speak louder.
Oleic
acid and linoleic acid. You do have mainly three. Are we together? Good. So this is what is happening? You start with your palm oil, you mix it with alcohol, which is ethanol, and it's gonna give you the glycerol, plus this is your ethyl ester. Remember, from the esterification, when you get your trans esterification products, these are called also esters. But because they are deriving from an alcohol, which is ethanol, you must call it ethyl esters. Are we together? Which is actually your biodiesel. And this is how it works. And you see, mastering the chemistry of this process is the key, because it relates to your catalyst. Is it okay? Good. And now, what is happening? The apparatus, you know already the chemistry. This is the apparatus. You must heat up everything in the bath. It's coming. You need to heat up everything, putting in the hot bath, and using a flask where you put your oil, your ethanol, palm oil. You need alcohol, you need your catalyst. Now you can go to the lab. But before going to the lab, you need to know what amount. You must know what amount of alcohol, what amount of oil, and what amount of catalyst you need to put together, and what temperature. And these are the parameters that engineers supposed to know how to control: the temperature, the pressure, the stirring speed, and so on. So this is the apparatus which is used. They use a temperature controller, which is there, and this is the heating bath, where they're gonna put the round flask where they will mix everything. This is the thermometer to read also the inside temperature of the mixture, and this is the head stirrer, which is used to mix homogeneously the solution inside. And basically this is what was happening, and this is what currently your friends are doing. They start with the palm oil, the ethanol, and this is the catalyst. They mix everything in the flask, and this process, as I said, is the trans-esterification. Once they got the products, they let it to settle for a certain number of hours, and then they separate. After the separation, they got the pure biodiesel and the glycerol. Eventually, the catalyst that will be extracted from the mixture can be recycled. So this is basically, okay, you cannot see the picture, I mean the video. The video here we were showing just how the magnets was picking up the catalyst after preparing the biodiesel.